All right. Hello, everyone. You may be wondering why you're not seeing Patrick Hingle here. Well, I am actually pinch hitting for Patrick today on this webinar. So if you saw my one last week, you get to see me do this one this week, which is great. Today, we're going to talk about biosolids remediation and removal. For those that were here last week, we talked about the impacts of excess biosolids and how to measure them, how to measure the biosolids. So that's a really good precursor to this webinar. I'm going to go over some of the similar things that I went over last week, just to kind of refresh, and because they're critical. But if you didn't get a chance to see last week, I really encourage you to go check it out. It'll eventually find its way onto our Lagoon University site, so you can watch it on demand and probably on YouTube as well. So I'm Patrick Hill. For those who don't know me, I'm one of the founders of Triple Point. I've been working with lagoon systems for the past 17 years. I probably worked on, I don't know, 100 to 200 different lagoon upgrade projects over that period of time. I've learned a lot, so I'm kind of here to share my knowledge. I'm gonna click off my webcam now and we'll get going. So this webinar is part of our new sort of Lagoon Masterclass series that we've been rolling out over the last couple of years. Eventually, there'll probably be between 12 and 15 different modules within the Masterclass series. And you'll be able to get on our website and on our Lagoon University platform and watch all these modules, just like you've been able to watch all the modules that we've done previously, and all the webinars we've done over the last 10, 15 years, and watch them on demand for free, get PDH credit if you're an engineer, or get CU credit if you're an operator. We're not approved in every state, and some states don't pre-approve, or they don't they don't approve online CUs or different things like that, but we try to get approved in most states that we could. So this is a really huge resource. Eventually, once we finish the Lagoon Masterclass, we'll put it all on Lagoon University site, and we will give you, you will be a certified Lagoon Master if you go through all these webinars on our site. We've got this, we had last week, biosolids impacts and measurement. This week, we're talking about remediation and removal. And then next week, we'll be talking about lagoon hydraulics, and that'll be wrap up our spring webinar series here. Next week, Brady's supposed to be doing this one, and I hope I don't have to pitch in for him too, because it's a lot of work to prepare for this, but it should be Brady next week to talk about lagoon hydraulics, which is also a really critical topic. So, I did this last week and I'll do it again, but you're probably wondering, why there is a picture of a warrior here on the screen. Well, in Greek mythology, Achilles was the greatest of all the warriors. And it was thought that he was immortal because his mom grabbed him by his heel and dipped him in the river Styx. And everything above his heel cannot be hurt, cannot be killed. And his heel is his weakest point because of that. So hence the phrase Achilles heel. And I think that biosolids is really the Achilles heel of a lagoon system. You can throw a lot at a lagoon. However, if you have too many biosolids in it, it is not going to work the way it's supposed to work. The fact is that every wastewater treatment plant in the world has to manage biosolids in one way or another. Lagoons manage them by storing them over a long period of time, over 20, 30 years. And so by definition, every lagoon has sludge to some degree. This is by design. And at some point, you need to manage that sludge. And you need to remove that sludge. And so this is just a feature of lagoons, not a bug, right? And so a lot of the problems that people see with lagoons, and when they say stuff like, my lagoon stopped working, or my lagoons don't work, or my lagoon stinks, it's usually because they had never managed the biosolids. And they don't remember who did last time or how they did it and so on. So it'd be like driving your car, never changing your brakes or maintaining your brakes, crashing into something and saying, well, my car doesn't work. Well, your car works just fine, it's just you didn't change the brakes. and you got to change the brakes every once in a while. And so today we're going to talk about when you should remove sludge, how to do sludge testing, strategies for limiting sludge buildup, including in situ sludge removal, a little bit on lagoon screens as well, because that can mitigate some of the sludge buildup speed, and then ultimately how to contract and budget for your sludge removal. So this is a pretty practical class today, and I hope you get to learn a lot if you're looking at removing biosolids. So when should you remove sludge? Well, generally speaking, lagoons are designed to have about 2 feet of sludge storage, or 18 to 24 inches of sludge storage. And this is a gross generalization. In fact, every state tends to have different guidelines on how lagoons should be designed and how much sludge storage they should be designed into them. So don't beat me with this, but just sort of as a general rule of thumb, it's about 18 to 24 inches. So if you have that or are approaching that level of sludge, then yes, you need to consider removing sludge. From a time perspective, generally they're designed for 20 years in municipal, 10 years for industrial, but this can obviously vary quite wildly depending on the flows and loading to your plant. And I would say I've seen lagoons that you have to remove sludge every 20 years on the button, and I've seen lagoons that have gone 30 years without removing sludge. Right? Wouldn't recommend the 30 years, but if you start getting into that age range of 20 years, you really ought to start considering it. And then finally, and we went through this in sort of great detail last week, was talking about in the last module, like we're talking about all the things that you would experience, right? All the issues that you would have if you had too much sludge. You'd have low dissolved oxygen. You would be unable to treat your BOD through the lagoon. You would have lagoon turnover, which would create lots of odors for you, and floating sludge, as you can see in this picture here. This is a pretty horrendous example of floating sludge. Good time to remove sludge. When you got sludge floating on the top of the water like that, not good. You can have pH issues, and if you're having lots of algae issues, then all of those are good reasons to think about removing sludge. The lagoon is telling you something when it gives you these things, and it's telling you, I need my teeth cleaned, and you better go clean the teeth, otherwise you're going to have problems. They're only going to get worse. They're not going to get better. So 4 basic steps to biosolids management in the lagoon. The first one is to measure your sludge. Can't tell you how important it is to understand how much sludge you have. Mitigate. Second step is to mitigate with screening and potentially in situ sludge reduction. And so we're going to talk about that. Budget your dredging method. Understand your dredging method. Understand how you're going to do this. How are you going to remove the solids? How you want the contractors to dewater the solids, and then where you want them to dispose of the solids. Those are the 3 steps to budgeting your dredging method. And then finally, contract dredging and verify removal. And I get some nice horror stories I'll share with you on when you don't verify removal of sludge. It can be a bit of a problem, but you do definitely need to double check things at the end. So measure your sludge. We'll talk over a few things I talked about last week. I'm not going to go too much into detail, but I wanted to recap these because they're super important. So as you can see here on the right, we have a picture of a sludge survey test grid. And this is what you need to do if you're going to measure your sludge. You need to get at least 18 to 30 different measurement points. And you do that by setting up a grid in the lagoon, staking it off, getting someone in a boat with 2 guys with ropes on either side, holding that boat, taking it to location, doing the reading, and then moving on to the next location. It is a survey, and so you really got to get out there and survey the whole entire lagoon, not just 1 or 2 spots. You want to use multiple measurement tools. I see, for a good example with this is I see a lot of these sonar boats out there that people get a service to come in, and they'll float the boat around, and they'll get you a nice little cool sludge profile and all that stuff, and that's all well and good. But if you don't have that sonar calibrated correctly, which means it understands when it's hitting sludge versus not hitting sludge, and if you don't pull a core sample, then you're really not doing a very good sludge survey. And unfortunately, when you do that kind of stuff, you've got to get out in a boat. There's just two ways around it. I think the sonar boats can be helpful to give you a general sense of the overall sludge levels in a lagoon and give you kind of a wind vane. But ultimately, you also need to get those core samples, and you need to get those core samples of the sludge in 6 to 12 different spots within the lagoon itself. Now, it's okay to take 6 to 12 core samples in Lagoon 2, for example, that's here, and then put them all in a bucket and take a composite sample to the lab. But you definitely want more than one core sample of sludge per lagoon. You definitely want multiple. And while you're out there, if you want some extra credit, I encourage you to do a DO profile of your lagoon, test the dissolved oxygen using a dissolved oxygen probe at 2-foot increments from the top to the bottom to understand how well oxygen is distributed throughout your lagoon and how well your lagoon ultimately is mixed and aerated. Because if you do get anaerobic pockets in the lagoon, basically pockets where you have very little or zero oxygen, that's what creates odors, and you don't want that. So, and you also get less treatment from anaerobic digestion. So I think it's good. It's really cool to be able to do a DO profile and see how well distributed oxygen is throughout your pond. Because since you're already on a boat, you're going to take these points anyway. So you get your sludge measurements, and then you need to analyze these measurements. So here's the table of all the sludge measurements that we took within that sludge survey from the picture before in the last slide. We've got Lagoon 1, Lagoon 2, Lagoon 3. We've got total depth in that location because lagoons aren't perfectly flat. They're all earthen basins. There's different depths at different parts of the lagoon. And then we have the sludge thickness that we get with our Secchi disc, which again, you can look at the last module for how we do that. And then we can determine overall water depth and sludge depth, right? And so this shows you each lagoon, Lagoon 1, Lagoon 2, and Lagoon 3. Obviously, as we might expect, Lagoon 1 has the most sludge. That makes sense. That's where all the solids are coming in, and that's very typical. What is interesting about this sludge survey, though, is that Lagoon 2 seems to have less sludge, or more sludge, or less sludge, sorry, than Lagoon 3, which is a little counterintuitive. You would think that Lagoon 2 would have more since it's closer to Lagoon 1. However, it kind of makes sense. This is an aerated lagoon. We do create mixing in an aerated lagoon system, and those solids do eventually float to Lagoon 3, and Lagoon 3, in this case, is a completely quiescent lagoon with no air in it. And so it's essentially a clarifier, and it's doing its job apparently because it's got more sludge in it than Lagoon 2 does. As you can see in this survey, they've got some points of 3.2 feet at the peak in Lagoon 1 in terms of sludge, and then Lagoon 2 and 3, they've got, one's a little under 2. So in this case, I would definitely sit there and say Lagoon 1 needs to be dredged. I would also recommend Lagoon 2 and 3 be dredged, given since you're already gonna be out there dredging lagoons, right? You might as well get all of them cleaned out while you're at it. So super important. The next thing, once you know your depth, you want to establish your volume. Sludge volume is super important for bidding contractors to know if they're going to remove sludge. It also tells you, again, your depth tells you when you kind of need to remove sludge based on that sort of 18 to 24 inches. And volume kind of gives you a sense of, if you're trying to budget for that, how many cubic yards or cubic feet in this case of sludge that you need to remove. So you can do this in 2 ways. Really, a volume calculation is a volume calculation, so it's depth times width times height. You can do this by the grid. So you set up a grid in your lagoon. You can kind of decide, well, hey, each measurement point's in the middle of each grid point. So these grids are X by X, and then you can figure out how much sludge is in each grid, and then determine the overall sludge levels. or you could just take an average. So Lagoon 1 has, you know, an average of 2.5 feet of sludge in it. You know, I know Lagoon 1's square footage is this. It's sludge depth times square footage. Boom, cubic feet of sludge. And then finally, you took those all important core samples, you listened to Patrick, and you went out on a boat and you did what you should do, got your composite sample of sludge, you sent it to the lab, you asked them for a volatile solids readout of the sludge, and this is the number they gave you. They gave you 35,000 milligrams per liter of total solids, and they said 16,990 of that are volatile. So you could sit there and say, well, I know that 48.6% of my sludge is volatile. Now, why do you want to know this? Well, a couple of reasons you want to know this. It's good to know for if you're going to bid a dredging project. You can also get the lab to do heavy metal testing on this sludge core sample, which is also going to be really important for your bidding contractor to know, and what ultimately your disposal site for the sludge will want to know that. But if we determine that we have 48% of our solids, for example, or in this case 22% of our solids are volatile, that means that we know we can break down potentially in place, in situ, that portion of the sludge blanket. And that tells us, is it worth it or is it not worth it to consider in situ sludge removal? I would say if you had 50% volatile solids, 100% worth it. And we will talk about in situ sludge removal because we know that 50% of that solid blanket, 50% of that mass can be broken down aerobically or anaerobically within the pond itself, right? And that means we can reduce our sludge blanket size by that much. So really, really critical to know that number, and both from any point of view, and it also gives you a general indication of how old your sludge is. Older sludge tends to have more non-volatile, and younger sludge has more volatile components to it. And so it's just, it's a really good metric to know to evaluate your current sludge levels. So let's talk about, we've measured our sludge. Now what we want to look at is how do we mitigate our sludge buildup and how do we remove some of that sludge in place without having to necessarily get out there and physically remove it. So the first thing I recommend is screening. So a big portion, if you don't have good screening, a big portion of your sludge blanket is going to be essentially the rags and trash and different things that flow in from the collection system. And you know, these are really complex organics, and so they take a long time to break down, and they will break down over time, over 20, 30 year period in the sludge blanket, but it takes a really, really long time. So they really tend to increase the volume of your sludge blanket a decent amount over that period of time. So if you can remove that stuff, then you are reducing the speed at which your sludge blanket is building up. You're reducing your sludge accumulation rate. So that's huge. The other sort of fringe benefit, two fringe benefits of having screening in your lagoon is ahead of your system is if you have aeration, those rags and all those things that we all hate and clog up pumps, well, guess what? Those things also clog up aerators. And I don't care what kind of aeration you got, it is going to clog it. Because aerators move water, and as they move water, they're sucking water towards them, and they're going to get clogged with rags. So super important. It really reduces your maintenance if you're able to screen before it gets in the lagoon. The second fringe benefit is that you reduce your BOD loading. There is a decent amount of BOD tied up in all those solids that are coming through your system that if you take out ahead of time, you're really reducing your BOD loading on the system, and it can actually perform better, right? And so I'm talking about a fairly simple screen, and I'll give you some examples here of what I've seen in lagoon systems. But you know, they can take out these materials, they can dump them in a trash can. You got to take that away, and you do have a maintenance item. Sure, you've got to maintain the screen, and you got to maintain the little motor on the screen. and whatever motors and bearings and so on that are there. But I think you're sort of trading maintenance. I think you're trading the maintenance of deragging your aerators that are in the water for maintenance that's on shore that you can get at, right? Or you're trading the maintenance of removing sludge for maintenance that's a lot more cost effective and has other benefits to it that help you out. And I like personally, if I'm going to maintain something, I like to have it on shore where I can access it. So that's why I really recommend screens to help you do this. So in lagoons, there's sort of 3 different types that I want to kind of explain. You have your bar screen, and it's very common to see this sort of manual bar screen set up, as you can see here in this picture. You've got these bars, they maybe have 1-inch gaps between them, and the water flows through the bars, and any of the trash that's smaller than, or larger, sorry, than the 1-inch gap won't go through, and the trash that's smaller goes through. And so these can be really inexpensive. This guy's raking his off. You got to go out there maybe once every week, or I would say actually probably once every weekday, probably a good idea, and rake it off. It can fit into a channel and super cheap to put in. So I would say this is a good approach. This is better than nothing. Although I think the mechanical bar screens, the mechanical perforated plate screens that we'll talk about here in a minute are better from a point of view is they're going to get more out. But having some kind of screen is super great, and I really highly recommend it. If you don't have a screen, you really need one. It's really going to reduce the amount of solids that build up in the bottom of your lagoon. So the issue with the bar screen is that it doesn't tend to capture all the solids, and things can squeeze through the bars, and then if you don't clean it, it'll ultimately just overflow, and all the screenings will just go directly in the lagoon anyway. So there are a number of other types of screens that are more mechanical and automatic in nature. This is a perforated plate belt screen, and basically the water flows through this belt that's on an incline, and it will automatically raise all the solids that get captured by the perforated plate material and dump them into a trash can. Or it will also take them and dump them into a compactor and a washer compactor that will actually just kind of wash them off a little bit and then compact them down, squeeze some of the water out of them, and then dump them into a trash can. And so these are great. They're pretty, straight up operation. They operate continuously. They automatically will clean themselves off when they need to be cleaned off. They can really capture a lot of those solids. If you look at the screen perf on this, not a lot's going to get through there, which is great. But on the downside, it's another maintenance item, and I think one of the beauties of lagoons is that they don't have a lot of maintenance items. And so you do have to consider whether you have the manpower to properly maintain a piece of equipment that's any kind of mechanical equipment within a lagoon. And the other side of this is that you might need an additional washer compactor setup. You get the screen, and then the compactor washer compactor is generally separate. So there's definitely some costs associated with putting in a screen like this. Another one that I've seen that's very similar, and I've seen this probably at more lagoons, the most lagoons that I've been to, is this is an in-channel screen. It will typically fit within an existing influent channel. So if you have a manual bar screen now and you want to add this will typically fit in the channel. And it's basically a 2-part setup. There's a grinder first, and so the water flows through there and any particles get ground up. And then you've got this, this perforated drum that the water flows through with this auger that will actually scrape off all the stuff that gets caught by the drum in this little screw mechanism. Ultimately, the screw mechanism will kind of squeeze some of the water out and then dump it into a trash can on the backside. This particular one, I took this video at a facility that actually receives influent from a prison. If you didn't know anything about prisons, they're notorious for flushing all their trash down the toilet. And so this is a real stress test case, and the operator who operates this said he's really pleased with it. It works really well, and so on. But again, there's motors here, there's maintenance here, that kind of thing. But screens can be a super useful tool for operators to kind of make their job a lot easier from a maintenance standpoint and ultimately lower the amount of sludge that builds up in the lagoon over time. So in situ sludge removal. So what is this? Well, as we talked about at the top of this call, we have we did our volatile solid testing, right? So we know how much of that sludge is organic, volatile, the stuff that we can break down, and how much of it's not. And so if we can break that sludge down in place, if we can take, let's say 50% of that sludge is volatile and we can cut that in half, then we know we can reduce our overall sludge volume without having to get a dredging contractor out, without having to remove these solids, without having to do any of that stuff, right? And so this is going to be, potentially cheaper and faster than, cheaper and easier, I should say, than actually physically removing the sludge. You will get a benefit in your performance of your overall lagoon because now you've reduced the sludge blanket, which means you have increased the amount of volume of water in your lagoon. Now you can hold more water because you don't have as much sludge in there, right? Which means you're going to get better treatment. And then this can prolong the interval between when you got to desludge. And the more you can prolong it, right, the more money you'll save in the long run. And so I think in situ sludge removal for me is kind of a must consider type of thing if you are approaching the levels of sludge where you think you need to remove, because it's going to be a much more cost-effective way to reduce your sludge volume than getting in there and physically removing that sludge. So what are our options here? Well, we have some low-cost strategies. We've got bioaugmentation, and then we've got aeration and mixing. And then I have a little case study I want to share on aeration and mixing. So first, the low-cost strategies. So this is a picture of kind of a chain drag setup. And so this is definitely, you can buy this on Amazon, maybe a couple $100. And what I've seen operators do is that they'll actually, they'll tie this to their boat and they'll put a trolling motor on the boat and they will just go around the lagoon and drag this chain on the floor of the lagoon. And what this does is it actually turns over some of the sludge, and you'll see all the little sludge bubbles that come up, and that's some of the H2S and different stuff like that that's being released as a result of you kind of mixing up the sludge blanket. But this could be a really cheap and easy way to reduce sludge. It really is. I mean, I've seen some fairly decent success with this kind of thing. And for the cost and so on, it's definitely worth a shot. The second thing is, if you have aerators and they're in certain locations, what you tend to see is that the aerators have an area of influence around them. And unless your lagoon's completely mixed, and most lagoons are not completely mixed from an aeration standpoint, if you move your aerators around a little bit, that'll actually help move the mixing around, which will ultimately help to break down some of the sludge in those other areas. And so you can just reposition your aerators, So these are really, both these methods I think are really good ways to use the assets you have in order to get, decent sludge reduction without having to spend too much money. Okay, the second thing we've seen a lot, and we've got some experience with this at Triple Point, is bioaugmentation. Now, I think the industry for bioaugmentation has gotten a bit of a bad rap because there seems to be a lot of sort of, especially at the beginning, some snake oil salesmen out there, people that really don't know what they're doing. And so you kind of have to be a little concerned and a little, I'd say, wary of who you're buying it from and their qualifications to know what they're doing. But the idea here is that you're putting into the lagoon special bacterial blends that are designed to break down some of those more organic, complex organics that are on the bottom, and really try to lower the sludge blanket by basically giving it more bugs, right? And this can work. I think you can get 30 to 60% reduction in your volatile solid portion of your sludge. One example here that I'll share is from our buddy Steve Harris. He was working with a company called CBX Pro Oxidizer. One of the other companies that we worked with is called Aquafix, and they're great. But what he did was he did this little study. He said, okay, look, I'm gonna take a sludge survey of this lagoon, Culver City, Kentucky. I'm gonna do a before sludge survey. They're going to apply the product, right? I'm then going to do 2 further surveys over the course, 1 a year, more or less, over the course of the next 3 years and see what happens. And so this is the way you want to set it up. And of course, he did his volatile solid testing. Steve is my mentor in this regard. So he knows his stuff. And what he found was he was able to reduce the overall sludge volume by almost 30%, which is huge. And that potentially saved about 100K in dredging costs. And so when you think about, they spent 20K on, $20,000 on this bioaug, they saved 100K in what they're gonna have to pay the contractor. That, their ROI is about 80K, right? So that's pretty darn good. I'd say I'd take that ROI all day long if I was investing personally. And so this can be a really, really effective tool. The second thing to think about is aeration and mixing. And so, what we often find with lagoon systems and old lagoon systems that are currently aerated is that they're either using older types of aeration systems such as surface aerators, or their existing system isn't working very well, right? It's old, it's been there for 15, 20 years, and it's not doing the job. It's not mixing, it's broken, it's got some issues with it, right? And so when we are able to think about replacing an aeration system, we could help. Part of the reason for that, part of the rationale behind that is that we can potentially get some sludge reduction in the process, right? So I kind of refer to this as like you're killing 2 birds with 1 stone here, right? You've got a aeration system that's old that needs to be replaced, and you also have sludge buildup, probably in part because your aeration system is old and needs to be replaced. And so what can we do here? And so here it shows you kind of on the right, a surface aerator, for example, slightly older technology, not very great at mixing. There's lots of dead zones, won't generally mix down to 15 feet of water depth or 10 foot of water depth. And so you tend to get sludge buildup when you have surface aerators in a lagoon. If you replace that with more of a diffused aerator on the left that sits on the bottom, that's going to create mixing, that's going to add oxygen, that's going to help break down the sludge blanket at the bottom, right? Clearly. And so you can kind of do that upgrade, get some sludge reduction, also get some energy efficiency associated with it, with a newer technology, with an aeration system, and really kill 2 birds with 1 stone. So we did a case study on this exact idea. This was actually a cooking oil plant in Louisiana, and they just had a lot of sludge. This was a 15-foot deep lagoon that in spots had 10 feet of sludge. I kid you not, 10 feet of buildup. That's insane. When you think about that, first of all, it's a lot of sludge to remove, so that's costly. Second of all, how much treatment volume are they losing when 2/3 of their depth is eaten up by sludge? They're losing a lot of treatment volume. So clearly a need here. So we came to them and said, hey, would you be interested in doing a pilot with us? We want to test what we can do to break down your sludge in place using aeration, and demonstrate to you that aeration really works well. So as you can see, they had lots of surface aerators on this pond. And as you can also probably see, they had, we set up they had an existing baffle curtain right here. This straight line here is their existing baffle curtain on the sort of this heavily aerated zone kind of near the bottom. And then we added a second baffle curtain up at the top to create a really defined pilot testing zone, right? We wanted to see, we didn't want to have the interference of all the other surface aerators that were there. We really wanted to understand what happens with our aerator in particular in this scenario. We, of course, as I've been banging on about for the last 2 modules here, we set up a test grid. and we did a sludge survey. And this is our test grid here. We have 18 different points. We have 2 columns and 8 rows here, or 9 rows. And so we really wanted to understand within our test zone how much sludge was there, and we did that by using a sludge judge to get our total depth, also using it to get core samples for our volatile solids, and then using a Secchi disc to measure our sludge depth. So how much water above the sludge is there, so that we could determine what the sludge depth at each location was across the whole entire test zone. So here's our data. This is sludge depth in inches, and as you can see, we set it up. We've got our blue part of this graph here is our first study, our first sludge testing. The red is the second, and the green is the third, and we clearly reduced sludge across the board over this 1-year pilot period. Ultimately reducing about 36% of the sludge overall, with a median sludge removal about 44.44%. So super great data. This kind of shows you where in each row in each test grid the sludge went, right? So the green is we removed lots of sludge. The red is most likely that sludge just got kind of moved around, right? We didn't, add sludge. That's impossible, right? But we, if you look at, 8A there, we had 100%, sludge removal down here. But then, of course, we had 57% increase in sludge here. So clearly, we just moved some of the sludge, right, from this grid to this grid. And that's kind of what happens in lagoons, right? Things get moved around. But the overall throughput of the study was, we managed to increase their treatment volume by 72.4%. We managed to decrease their total sludge volume in terms of cubic feet by 44.3%. So that's huge sludge reduction. It's almost, it's almost 1,200 tons wet, and it's probably 522 tons dry once you factor in the water content. And so we saved this facility about $522,000. So huge efficacy associated with breaking down sludge in place for these people, of course, because they had a lot of it. But also, we provided aeration that's more efficient. It's easier to operate than their surface aerators are. So we really killed 2 birds with 1 stone here for this facility with great success. Okay, so we measure our sludge. We now know how much, how much sludge we can reduce in situ. We've done that. Now we got to think about dredging. Okay, so how are we going to do this? Well, there's 3 components to dredging. There's the physical removal of the dredge material, the sludge itself. There's the dewatering of that sludge, because you don't really want to haul water. Water's pretty heavy, right? And then there's the disposal. So we're going to talk about each 3 of these and the different options. So the first one, and probably the most common one that I see, is wet dredging. Wet dredging is this picture here is a great illustration. You have a boat, you have a dredge with a dredge head on it. That dredge head kind of acts like almost like a vacuum cleaner. It is spinning and funneling everything into a pumped line that's then pumping the dredge material out. And so this can be really great. I mean, I think the main benefit of wet dredging is you can keep your lagoons online. You do not have to take them offline. They will work. It will work just fine. The downsides, I think, are that it's hard to verify sludge removal. The dredge head itself tends to kick up a lot of sludge as it's sucking up sludge. And so that can kind of kick some solids in the water column, and you can get out there a week after dredging and measure it, and it doesn't seem like you got a lot of sludge, and then get out there 3 months later and measure it again, and it's like all that solids that were kicked into the water column have settled down, and you find that you didn't get out as much out as you thought you got out. And I got a funny story about that in a bit. If you have diffusers in the bottom of the lagoon, the dredge head really needs to work around those, and you got to make sure you're not going to break them, which can be hard sometimes. If you have a synthetic liner, super important that you get, that you don't puncture that liner. I've heard of that happening before. It can happen with wet dredging. And ultimately, I think you want a good contractor with good qualifications to avoid all of the aforementioned issues associated with wet dredging. This isn't my personal favorite way to do it. Personally, my favorite way to do dredging is to take the lagoon cell offline, get down there, with your contractor, get down there, physically remove the sludge. Why do I like this so much? Well, I can see that this lagoon right here that we're looking at doesn't have any sludge in it. I can see that. You can see that. There's no debate about that. There's no sludge in here. We don't have to worry about that, right? And so I think that that's huge. You can see the clean basin. You can make sure you work around aeration. If they've got aeration, you can fix, if there's any damage to the liner, you can fix it before you pull the pond back up. You can let the solids hang out there in the bottom and let them dry for a couple weeks, right? And that works, I mean, I recommend you get in there and turn them at one point, kind of move them around at one point, because otherwise the top layer will dry and the rest of it won't dry. But it can be a way to dry them as well. And so if you can do this, this is by far the best approach to dredging, in my personal opinion. I understand that everybody can do it this way, but this is the ideal way to do it. So once you've got the material out of the lagoon, now you got to think about, well, how are we going to dewater this? And I think it's important to contemplate this on the front end. And there's really two ways to contemplate it. I mean, one way to do it is say, just put it on the contractor. Say, hey, contractor's responsible for dewatering sludge to X%, right? And what they'll typically do is they'll bring in some kind of mechanical equipment, either a belt filter press that will, a belt press that will basically squeeze the sludge and squeeze the water out of it. Or if you want to contemplate it ahead of time, what I've seen a lot of these days are these geotubes, where the contractor will literally pump the sludge out of the lagoon, pump it into these geotubes. He has to set up an area, containment area for the geotube, so that it will collect the water and ultimately put the water back in the lagoon. And then you just let the geotube sit there, and over time, the water seeps out or evaporates, and it dewaters itself basically on your site. And then after 6 months or a year, you come up, you pick up the bag, and you dispose of it at that point. And so I think the geotubes can be a little bit less expensive as an approach in some cases. It really kind of depends. But both of these methods are important. So if you're going to do the geotube approach, you really need to contemplate that on the front end. Otherwise, if you're going to do mechanical dewatering, then it really kind of comes down to the contractor and how he wants to do it. Once you've got your dry solid, you have to dispose of it. And this is another area where I think there's some really helpful to have some pre-contemplation about how you're going to approach this. You can take it to a landfill, and if you're going to do that, the solids need to be dried. They do want testing on the sludge to know what's in it. And ultimately, you're going to want to get that pre-approved by the landfill if you're going to take it to a landfill. And I think it's good to have that ahead of time, because I think that's going to create a level playing field for all the contractors. If they know, hey, I got to remove the sludge, I'm going to take it over here, then you get better prices across the board. The second way to do it is land out. And this is really common in the Midwest, where they take the sludge and they land apply it. And you can do this wet, so you don't necessarily have to dewater. I've seen it done wet. I've seen them pump directly from the lagoon, run a HDPE pipe directly to the field, and land apply it at the same time. Now that is the gold standard of land out, if you can get that done. So you don't even dewater. That's by far the cheapest way to do it. But if you do have to dry it, then it gets applied onto a farm field. This also needs composition testing, and a permit is required from the state for land application. Again, something really good to have ahead of time, where you're going to dispose, how you would propose disposing of it, and have a general idea. Because if you can create a level playing field for all the contractors, then they're going to give you their best price. You're going to get the most competition. So now you've got your kind of methods, you've done your pre-planning. How do you contract this sludge removal? So I would say again, goes back to being prepared. Have a recent sludge survey, have your lab testing, understand where you're going to dispose of the sludge, and write your specs and your contract to remove, to have a volume-based removal calculation for this desludging. How many cubic yards do you want to get removed? How many dry tons do you want to get removed? And then build in the verification methods for this. Trust but verify. I cannot tell you how many times I have been told that, oh yeah, we removed sludge last year, and we get in the lagoon and we look at the sludge levels and we're like, did you? Did you really? Because it doesn't seem like it. It seems like you got 2 feet in here. And they're like, well, he said he took it all out. It's like, did he? I mean, maybe he tried, but it didn't work out. So I always like the trust but verify moniker here. Make sure that you're getting what you're paying for, because money is a scarce resource, especially for the communities and the industries that have lagoon systems. So really do that. To get that, it's all about the specs. You don't get what you want, you get what you specify. And you need to specify what you want and be careful about that. Typically, we're looking at a number of dry tons removed is what you need to specify. And you also need to specify how that tons removed is calculated. This is one such calculation where you take the cubic feet and you apply it to the percentage of water that you can measure within the sludge. That's a very objective test. What percentage of solids is in the sludge and what percentage is water, and you get your dry tons. And so you put in the contract and you say, hey, we want to remove 25,000 dry tons. Okay, that's what you need. And then once you figured out how many dry tons you got to remove, you got to figure out how you're going to verify that. If you do a dry basin, you can visually verify if you want, right? You can tell the contractors, here's this, we're going to visually verify. When we see it's clean, it's clean. The other way to do it is you can weigh. So a lot of these contractors, you get a tank, you weigh the tank, you fill it up with sludge, you weigh it again. You then also have your percentage of solids that you need to have before they weigh it, and boom, you know how much sludge is there, right? You know how much sludge is in that tank, and you just count it all up and you get your 25,000 dry tons, you're good. If you do a wet sludge survey, then you got to go back out and you got to resurvey the lagoon. If you're not going to weigh it before it leaves the site and you can't visually verify it, then you need to resurvey at the end. This is a funny story. We were doing a class with Steve Harris at a lagoon in Iowa, and a buddy of mine, Dan, who's the head of public works, just did a big project, and he's out there and Steve's out there demonstrating how to do a sludge survey on the lagoon. And he's like, hey, Dan, didn't you say you got sludge removed last year? And Dan's like, yeah, we came in here and cleaned out all ourselves, wet dredged the whole thing, right? And he's like, well, I don't know what to tell you, Dan, but you got 2 feet in here. And of course, it was like, head through the roof. What's going on? How did he have 2 feet? Well, sure enough, the whole lagoon didn't get as much sludge out as they were supposed to get out. Dan ended up suing the contractor. He had to pay another contractor to come out and do it again, basically. And guess what they did the second time? They did dry dredging the second time so they could actually see it was removed. So super important to verify. So finally, costs. Obviously, the costs are going to vary based on location, based on the type of dredging method that you're using, based on how you're going to dewater and where you're going to dispose of it. So all these things play into it. Really, really hard to generalize on costs when it comes to this, right? Are you in the middle of nowhere? Do you have a landfill across the street? What's going on, right? Well, I would say this is some data that I managed to get from a multi-site owner. Private utility owns, these 7 lagoon systems, has dredged these lagoon systems over the last 3 years. And this is the cost per dry ton, which is your columns there, and measured on the left-hand axis, and then your gallons per day on the right-hand axis. So I think what you immediately see here is that the more gallons per day that your system pushes, the lower the cost per dry ton is. Now, it's obvious that's because you probably have more dry tons to remove. If you are like the middle facility here, Lagoon 3, you have almost 3 mgd of flow, right? You're going to have more dry tons. More dry tons, it's going to cost less to remove because contractor's got to mobilize one time. You can get in there, you can get it all out, you can go. If you're smaller, then your cost per dry ton can be really high, right? If you're only removing a small amount of sludge, such as Lagoon 4, you have very little flow, it's a lot of mobilization, demobilization, all that good stuff. And so it costs them a lot. On average, across these 7 lagoon systems, it was about $1,300 per dry ton removed for them. And so, you know, that's sort of your average. In this case, I've heard a gentleman I spoke to who works for Spectrum who does desludging said $600 to $1,000 per dry ton. And so this gives you a good sense. And if you want to kind of back of the envelope this and say, well, my gallons per day, average gallons per day is, you know, X, then I kind of converted that into gallons per day. So it's 1 to 3 cents per gallons of average design flow of your system. And that's, I haven't back tested that or anything, but that gives you a general sense of what the cost could be if you need a budget. So this is, I want to wrap this up here. You know, biosolids are an inevitable part of a lagoon management, and if you don't manage them, they can really be the Achilles heel of your system. 4 key steps: you want to measure, mitigate, budget, contract, removal, and verify. I do recommend screening to help minimize sludge buildup. I think that's a really great tool. I do recommend in situ sludge removal, including bioaugmentation, aeration, if those things make sense to you. There's no sense in getting the contractor to remove solids that he doesn't need to remove because you can break them down in place. Your dredging method is going to depend on your situation, but we do really recommend dry dredging if possible. I think that's the surefire way to get it done. And when you hire a contractor, for the love of God, please verify their work, because I cannot tell you how frustrating it is to me to hear that sludge was removed and it wasn't actually removed. And so it's really important to build those verification mechanisms in place to make sure you're getting what you pay for, because I hate to see small communities waste the precious small amount of money they have when doing biosolid management. So with that, I'll open up to any questions. If you want to put them in the chat, Leslie, my colleague, will read them to me, and we'll
You're on the Patrick, you said that you need to measure DO at different depths in the lagoon. How much does DO vary by depth, and is there a way that flags if there's something going on?
Well, it can vary greatly depending on the level of mixing in the lagoon itself. Typically, you would expect the dissolved oxygen to be the highest within the first 2 feet of the water column, in part because that's where you have your air-water contact point, but also in part because that's where algae grows, and algae will photosynthesize and add dissolved oxygen to the water column. And then your lowest will be at the bottom, right, where your sludge blanket is, where it's primarily anaerobic. I think, and you know, in between, you get different levels of oxygen, right? As it goes down, it's like highest at the top, lowest at the bottom. And, you know, I think it's, you know, one of those things with lagoons is like, you know, they've talked about doing, automated DO control within lagoons. And it's like, okay, well, that's great, but where do we put the DO probe to get a accurate reading of the dissolved oxygen? Because it will vary from location to location. It will vary based on the elevation in the water column that you're at. It'll vary based on where the influent's coming in. That'll be lower than near the effluent at the back. And so you can get these massive differences. And I think just knowing where the DO is lowest, and it can be a good way to kind of help you plan where you put your aeration, if you move your aeration around, or even just, you know, give you a bird dog of what's going on in the lagoon and where you might need some help.
Do you stop discharging for a period of time when you're doing the dragging with chains?
If you can, I would recommend it. Not necessary. So like if you think about your first lagoon, typically being the one with the most sludge in it, that's probably where you would drag the chains. Because even if you do kick some solids into the water column, you're gonna have lagoon 2 and maybe your third lagoon there to help settle some of those solids downstream before they reach the effluent point. You may consider talking to the state about, the fact you're going to do this. I know with dredging that oftentimes you do want to notify the state that you're going to be dredging, and they'll usually give you some grace in terms of your effluent because you're trying to maintain your system better. So if you want to be super cautious, definitely shut the flow off or talk to the state and try to do it more on your first and second lagoon versus your last lagoon kind of thing.
What's the threshold number for in-situ treatment for volatile solids? What percentage would need to be volatile to make sense to try to do it in place?
Well, I think if you think about, it really depends on the volume, right? So I think if you think, there's only so much you can reduce. You're never going to get your volatile solid component down to 0. So if you targeted, let's say 50% removal of or a reduction in volatile solids, and you know what your ratio is, so you can kind of calculate how much volume that really is and versus the cost, and make a cost benefit analysis at that point. Because if you got lots of sludge and 30% constitutes 25, dry tons of sludge that's volatile, and you can reduce that by 12,500 dry tons of sludge, and that's going to save you, X amount of dollars, then sure, maybe that makes a lot of sense. But if it's less than that, then it doesn't make any sense. So I think you just got to do that analysis, quick back to the envelope ROI, and go from there.
How often would you recommend using bioaugmentation?
Well, I think, in a lagoon, if you've got a good aeration system, or if you have the right infrastructure in place and it's well maintained, you don't need bioaug. Bioaug can be helpful to reduce sludge because most lagoons are partial mix. So you're not getting complete mix across the bottom of that lagoon. Or maybe if they're facultative, they have no mixing really. And so bioaug really can help in those types of circumstances where you're trying to do something special, like where you're trying to do in situ removal. But if it's just day-to-day operation and you're using bioaug to supplement your day-to-day operation, chances are that you don't have a well-maintained system at that point, right? It shouldn't be a crutch. It should be used for the purpose of, for example, doing in situ sludge reduction so that it can save you costs when you remove sludge at the end of the day. But the lagoon itself should be able to grow its own bugs. It should be able to do its own thing in a normal circumstance.
You said the typical depth where you need to start looking at removing sludge is 18 to 24 inches. Does that translate to a percentage of overall volume?
No, not really. I think, no. It's just, I think that's just sort of a generally recognized rule of thumb for sludge depth, where it starts to be too much. And it's really designed, I mean, if you think about it, so, the state's sitting there and they're saying, okay, well, you need, for facultative treatment or aerated treatment, you need X number of days of hydraulic retention time. The water needs to sit there. And if we design for 2 feet of sludge, then, we don't have that hydraulic retention time anymore, and therefore your treatment level is going to go down. So I guess, from a treatment standpoint, yes, it does. You're going to see inevitably a reduction in treatment, and that's because your volume's inevitably less because you have more sludge.
Can you talk a little bit about using recirculation as bioaugmentation?
Right. So when you recirculate, what really happens when you recirculate is you're taking whatever's left from a BOD, ammonia, standpoint, and you're putting it back into the front of the system. And so, yes, there are some bugs, right? But most that are in that waste stream that you're recirculating back into the system. However, you know, there's not that many bugs because your BOD typically at the back of your plant's a lot lower. And if your BOD is lower, that means the food source for the bugs is lower, which means you don't have a very vibrant microbial community. But what does enhance why it does sort of bioaug in essence is that you're taking food that those bugs want to eat and you're putting it back to the front where you've got bugs that are where you do have a more vibrant microbial community, because that's where most of your BOD is, at the front. And that in turn feeds more bugs, that grows more bugs at the front. So it's a sort of natural bioaug in their sense, but it's more of a food-driven bioaug than just like an actual, I'm adding more bugs, if that makes sense.
We'll make this the last question because we're at the top of the hour. Can you talk a little bit about dry dredging and taking a lagoon offline and what happens to the incoming flow?
So typically what we see is that you will basically bypass the lagoon that you're taking offline. So if you're taking Lagoon 1 offline, that means your influent flow goes into Lagoon 2. And if you have aeration in Lagoon 1, you're putting that aeration in Lagoon 2 while you're dredging it. So you're basically just bypassing whatever lagoon and putting it into other lagoons while it's offline. It is essentially how it typically works. I mean, it depends on what your infrastructure is. But again, I think yes, you might not meet your permit limitations in that given month, right? But if you talk to regulators most often than not, and you say, hey, I'm removing sludge for these next 2 months, I might not meet my permit, but you got to understand, we got to get the sludge out of here because I'm not going to meet my permit if I got too much sludge. And they're going to be like, yeah, cool, no worries, we get it. You need to remove sludge, doesn't happen very often. We're cool with that. And they're usually going to give you a more relaxed compliance scenario. Okay, well, thank you all for coming today. I hope you enjoyed listening to it as much as I did being with you here and giving it. And, you know, if you got any other questions, feel free to email me here or give me a shout. I'll be happy to answer them. And we'll see you next time.